Welcome to another exciting educational video brought to you by Upvision Concept Academy. So in this series of videos, we'll be looking at past questions for the Common Entrance Examination Mathematics, and we'll be sampling the questions and solving the answers. So sit tight as we dive into these past questions. It promises to be an interesting experience. So I have on the board a baker brought 4 kg of flour. He used 2/5 of the kg on Monday and 1/2 on Tuesday. How many kilograms of the flour did he have left? So this kind of question, you have to total the amount of flour he used, the fractional one. So total flour used is equals to, so I have 1/2 plus 2/5. That's this 2/5 and 1/2. So you just find the LCM. The LCM is 10. 2 and 5 is 10, right? 2 into 10 is 5 times. 5 times 1 is 5. Plus 5 into 10 is 2 times. 2 times 2 is 4. So I have what he used is 9/10 kg. That's what he used. So what is now left is flour left is equals to 4 that was used minus 9/10. So this is simplifying the LCM. 4 is same thing as 4/1. 1 and 10, the LCM is 10. Then 1 into 10 is 40 times. 40 times 1 is, so the 1 into 10 is 10 times. 10 times 4 is 40, minus this minus. Then 10 into 10 is 1 time. 1 times 9 is 9. So whenever I do the subtraction, I have 31/10 is the same thing as saying 3 whole number 1/10 kg. I think the answer is A. Okay. Okay, so we have another question on the board here, number 52. It says, Mr. Kazim bought 300 boxes of sweets. Each box contained 12 sweets. He repacked all the sweets into packets of 10. How many packets of sweets were there altogether? So these are the options. So we're going to solve. So he bought these boxes of sweets, and each box contained 12. So how many sweets do we have altogether? So I'll come and say first of all, say the total number of sweets is 300 boxes times 12. 300 times 12 will give me 3,600 sweets. That's how many pieces of sweets we have. So he now repacked them into packets of 10. So each packet has 10. So how many packets do we have? So I'll now say the number of packets is equals to this total sweets, number of sweets, all over 10 inside. So this will give you 360 packets. So the answer is B. Move on to the next question. Okay, so we have this question on the board, number 53. It says, there are 156 people in Hall A and 84 people in Hall B. After 29 people left Hall A and some people entered Hall B, there was an equal number of people in both halls. How many people entered Hall B? So let's say this is Hall A. Hall A, and this is Hall B. So initially, we're told that there were 156 people in this hall. So, and 84 people in Hall B initially. 84 people in Hall B. But they said 29 left. So I'll just say 29 left. 29 left. When 29 left, if you subtract 29 from 156, how many do you have? You have 127. Why? Because 6 minus 9, it cannot go. You borrow 1 from there. That is 16 minus 9 is 7. Then 4 here. 4 minus 2 is 2 and 1. So 127 left. Now for this to balance, he said there was an equal number of people in both halls. So when 29 left here, this one now become 127. They were both equal. So how many people now entered? How do you get this? Just say 127 minus 84. When you do the subtraction, the answer is 43. So 43 people now entered hall B to make the both of them balance. So the answer is A. So you see how you use diagrams to simplify the question. So move on to 54. Okay, so I have this question on the board. It says the length of the rug is 3/4 meter and the breadth is 1/6 meter. What is the area of the rug? So the rug looks like this. It's rectangular in shape. So we are looking at rectangular shape. So they said the length is 3/4 meter and the breadth is 1/6 meter. What is the area of the rug? Area of a rectangle is equals to length times breadth. So the length is 3/4 and the breadth is 1/6. So we're going to do fractional multiplication. So 3 here 1, 3 here 2. So 1 times 1 is 1, 4 times 2 is 8. 4/8 meter squared. The answer is C. So move on to the next question, number 55. All right, so we have this question on the board. It says the mass of a tin filled with some candies is 200. Another identical tin filled with some biscuits is weighing 860 grams. The biscuit weighs 7 times as heavy as the candies. What is the mass of the candy? The mass of the candy. Okay, so I'm going to solve this. It's a word problem. It's a word problem. So first of all, we're told that the mass of a tin. So let's say mass of a tin plus candy, because it's filled with candy, is 200 grams. Another identical tin, so the same kind of tin. So I will say again, mass of tin plus biscuits is weighing 860 grams. So they said biscuit weigh 7 times the mass of the candy. What is the mass of the candy? So biscuit is equals to 7 times candy in gram. Now this is a word problem. So I'm going to represent all these things I'm saying in alphabet with algebra. And just follow me closely. So if the mass of the tin is T, mass of the tin is T, plus mass of the candy is C. Both of them will give me 200 for the first one. Second one, mass of the tin T plus biscuit B will give me 860. So there are three, this is the first equation. This one now, they say biscuit is equals to 7C. So, and B, which is biscuit, is equals to 7C. Okay, so now I have 3 equations here, 3 equations. I'm going to solve this one simultaneously, 1 and 2. I'm naming 1 and 2. Just follow me, follow me. So this is 1 and 2. T is mass of tin, right? Plus candy, C, is equals to 200. That's this first statement right here. Then T again is the mass of tin plus biscuits. This tin, they're identical. They're identical. So don't worry about it, they're identical. But what is different is candy and biscuits. And they said the relationship between biscuit and candy is 7C. So if I come here and I say, I write 1 and 2, this 1 and 2 again. But when I'm writing number 2 equation, I will replace B with 7C because they say B is equal to 7C. B is biscuit and 7C is 7 times candy. They say biscuit is weighing 7 times as heavy as candy. Let me call this one 3, but I'm working on 1 and 2. So rewriting the equations again. So equation 1 will now be T plus C is equals to 200. I will say call it equation 1. But equation 2 is now T plus, instead of putting B, I put 7C. 7C is equals to 860, equation 2. So I'm going to subtract equation 1 from 2. Subtract it. That is, I'll put minus here. I'll subtract it. I'll rule line like this. So T minus T is 0, plus 7C minus C is 6C, is equals to 860 minus 200 is 660. So this is an equation I'm going to solve for C. How do I get C? Remember I said, what is the mass of the candy? How do I get C? I say divide both sides by 6. So I will say 6C all over 6 is equals to 660 over 6. 6 here 1, 6 here 1, 6 here 1, 6 here 110. So C is equals to 110 gram. That's the mass of the candy. So see what happens. First of all, you have a word problem like this. You have to write out what you are seeing here in terms of mathematics, in terms of numbers. I'll go again. So they say the mass of tin filled with some candy. So the mass together, tin and candy is 200. That's the first statement. Another identical tin. So the tin, it's like they brought a similar mass of tin. Another identical tin is filled with some biscuits. So the two of them weighs 860. That's this one now. They now put a third statement and say the biscuit weighs 7 times as heavy as the candy. So biscuit is equals to 7 times candy. So I'm writing it here in terms of algebra. So I have T for mass of tin plus C for candy is equals to 200, equation 1. Then second equation, I have mass of tin again, T, plus biscuit, B, is equals to 860, equation 2. Now this third equation 2 is where they say biscuit is equals to 7 times candy. Now this third equation, you are going to use it to put inside this one so that I will not have B and C. Because if I have B and C, I cannot subtract here. That is why I now, where I see B, I replace it with 7C. That's what I did here. So I now say subtract 1 from 2. I now rule the line like this. So I'm going to be subtracting this one from this one. That means this one will be on top. So T minus T is 0. 7C minus C is 6C. You understand? Because the two C's are there, and this one is 7. So 7, that's we are taking C as 1. There's a 1 in front of C here. That's the coefficient of C is 1. Understand? That's why I said 7 minus 1 is 6. CC remains. Then 860 minus 200 will give me 660. So I have this equation like this. 6C is equals to 660. So I can now divide both sides by 6 so that C will stand alone. So 6C over 6 is equals to 660 over 6. 6 here 1, 6 here 1. Then 6 here 1, 6 into this one is 110. That's why I have C is equals to 110 gram. That's the answer here. Okay, so move on to number 56. Okay, so we have this question on the board. It says 10 scouts were given 10 fun fair tickets to sell. That is each. 4 of the scouts sold 7 tickets each. The rest of the scouts sold all their tickets. How many tickets are left or were left? Okay, so I have 10 scouts given 10 tickets. Given 10 tickets. 10 tickets. So total number of tickets that we have is 100. 100. But they said 4 of the scouts sold 7 tickets. So if 4 sold 7, then out of 10, the remaining 6 sold everything. Sold the 60. Sold the 60. So I'm interested in what is left under 4. Under 4, what is left? So each had 3 left for the 4. Each had 3 tickets left, each of them. Each. 3 left each. Understand? So this 3 that is left each times 4. 3 times 4 is equals to 12. These are the number of tickets that have left. Another way I can explain this is that you will say, if let me take this one off. Take it off. So if I have 10 scouts giving 10 tickets each, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scouts. So I have 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. Right. So they said 4 of the scouts sold 7 tickets. So 1, 2, 3, 4 sold 7, 7, 7, 7. Out of the 7, 7, 7, this is sold 7. Left from 10, if you remove 7, you have 3, 3, 3, 3. This is where our concern is. All these guys sold their tickets, so I don't have any business with them because they sold their tickets. But this 3, this 4 did not sell. So how many left together? 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. So 12 tickets that we have left. So most of these questions, you need to just understand them. You can use pictorial representation that's trying to picture them. It's trying to test your logic, your reasoning. All right. So move on to the next question, number 57. Okay, so we have this question on the board. It says a box with a mass of 12 kg is 5 times as heavy as a bag. What is the mass of the bag? So if the box is 12 kg and the bag is S kg, but we're told that this one is 5 times as heavy as the bag. 5 times as heavy as the bag. So the mass of bag is 12 divided by 5. It's 5 times as heavy as the bag. 5 times as heavy as the bag. Okay, so 12 divided by 5. So how do we do this division? Okay, so 12 into 5. That's 12 divided by 5 is 2 times. You understand? It's 2 times. Remember what? Remember 2. So I have 2 over 5. That's 2 over 5, 2 over 5. But this one can be expressed as decimal as 2.4. That's kg. Hope you know how to express fraction as decimal. If I want to express this as decimal, this one, 2 over 5 as decimal, I will just do my division. Where 5 will be outside, 2 will be inside. 5 into 2 is 0. I put dot here, I add 0 here. I put dot, I add 0. So 5 into 20 is 4. That is why this one is carrying 0.4. Understand? So the answer is A. So we move on to number 58. Okay, so we have a question on the board, number 58. It says, Mary had 3 over 8 meters of ribbon. Beulah's ribbon was 4 times as long as Mary's ribbon. Find the total length of the ribbon Mary and Beulah had. So Mary had 3 over 8 meters. Beulah has 4 times 3 over 8, which will give us 12 over 8, because 4 times 3 is 12, then over 8. So total length is equals to 3 over 8 plus 12 over 8. So I wrote my line. LCM of 8 is 8. 8 into 8 is 1. 1 times 3 is 3. Plus 8 into 8 is 1. 1 times 12 is 12. So this plus this, 3 plus 12 is 15 over 8. Expressed as fraction. This is improper fraction. But as proper fraction, it is one whole number, because if 8 goes into 15, it's only 1 time. Remainder 7. So that 7 will be up here, then over 8. So the answer is B. Okay, so we'll move on to the next question, number 59. So I have number 59 on the board. It says find the value of 22 plus 14 divided by 2 times open bracket 14 minus 9. So this one is the mathematical expression that has more math operation, basic operation. So you have plus, division, multiplication, the bracket, and minus. So you apply the BODMAS rule. The BODMAS is an acronym that tends to help us to find the order of applying these operations, where B stands for bracket, again, O stands for off, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. So with this rule, you are going to follow it the way it is here, the way it's appearing here. Follow the order. That means when you see brackets in that thing, you start with bracket. If you check, if you see off, go, the next one will be off. If you see division, so you just follow it by what you are seeing, So we start. What is the first operation we are seeing here? It is the bracket. So let me write it out again. 22 plus 14 divided by 2 times, open bracket, 14 minus 9. So I'm seeing bracket first. I will solve this bracket. 14 minus 9. 14 minus 9 is 5. Understand? Then the next one is division. I'm seeing division here. So I'll just put times here. I'll do this one. 14 divided by 2 is 7. The next one is multiplication. Let me add this one like this. Multiplication. So I multiply this one, 35. Then I have addition, plus 22. So I add this to 2 plus 5 is 7. 2 plus 3 is 5. 57 is the answer. That is number D. So we'll go to number 60 for this video. So number 60 here says, which one of the following fractions is the biggest? A, 3 over 4, 11. B, 3 over 8. C, 3 over 7. And D, 3 over 5. Which one will you choose? They're all having 3, 3, 3 up. And they're having 11, 11, 11. Don't go and rush and put 11 as the highest. So you'll be surprised that 11 is the smallest. But let's see how it goes. Let's see how it goes. So I'm going to write out all these fractions and compare them. So I will say 3 over 11, comma, 3 over 8, comma, 3 over 7, comma, and 3 over 5. The best way to compare this is by ensuring that all the denominators are the same. So I'm going to rule a line to find the LCM of the denominator. LCM of the denominator. So LCM of 11, 8, 5, and 7 and 5. How do I get it? How do I get it? I just rule one line here. Are you seeing my line? So I'll write 11, I'll write 8, I'll write 7, I'll write 5. So I want to look for the lowest common multiple. So I start with the least number that can go into all of them. I put 2 here. 2 into 11 cannot go. But it can go into 8, how many times? 4 times. Cannot go into 7, cannot go into 5. 2 cannot go into 11, can go into 4, 2 times. Cannot go into 7, cannot go into 5. 2 again, cannot go into 11, 11, can go into 2, 1, 7, and 5. At this point, I'll look for the next one, 5. Cannot go into 11, cannot go into 7, or 5 here is 1. Then 7, cannot go into 11, so I write 11. 1, yeah, 1, yeah, 1. Finally, 11, 1, 1, 1, 1. So these are the multiples of this. So I will say 2 times 2, 4 times 2, 8. 8 times 5 is 40. 40 times 7, 40 times 7, 0 to 80. Then 280 times 11 is this is 280 here, and this is 280 here. So I have 8, 0, 8, 0, 2. So 20, 80, 80. I will just tell you how to quickly choose this, but let's see. Okay. So actually the answer is this, but let's just do it. Since you are doing common entrance, the quickest way to just check this thing is to look at it. Since all these ones are the same, numerator are the same, understand? And denominator are different. So the difference between denominator and numerator for the biggest one should not be should not be too much. This and this is only 2. This and this is 4. This and this is difference. This and this is 5. This and this is 8. 8. So this one that has the least difference between is the highest one. It's the highest one. This one, what I'm doing now is going to take a long time, but let's do it all the same. So 11 into 2, 8, 20, 80 is just what is left here is 280. 280 times 3. Wow, this is going to be long. 280 times 3 is 8. Okay, for the sake of this particular thing, let's just let me still do it. I will still do it. I will need to use a calculator, but for common entrance, you may not have time for this long thing. That's why I'm telling you what to do. Just hold up. Let me bring up the calculator. So 280 times 3 280 times 3. For the first one, I have 840, comma 8 into this. That is 280 times divided by 8. 2080 divided by 8. So when I do that division, I have 260. 260 times 3 times 3. I have 780. Okay, the next comparison is 2080 divided by 7. 2080 divided by 7. Divided by 7. Okay. 2080 divided by 7. Then times 3. Okay, hold up. 11 times 8 . All right, so as you can see on the board, I'll fix this. So the procedure is to write out the fractions, then find the LCM of all the denominators, which is 3080, not 2080 as I did previously, 3080. So 11 into 3080 times 3 will give me this. 8 into 3080 times 3 will give me this. 7 into 3080 times 3 will give me this. And 5 into 3080 times 3 will give me this. So initially I said that this one is the highest, because look at it now. This one has the greater number up here. So the principle involved in this is that, first of all, just put all of them in a common denominator and find their corresponding numerator and compare. You can only compare like this. But because you are doing common entrance exam, you will not have time to go through all these big things. They know that they're trying to test whether you can logically get the answer. So from here, if you have fractions like this, the numerator is the same thing. The denominator is different. You understand? You can compare the two of them. The one that has the one that the difference is the smallest is supposed to be the biggest. So look at it. 5 minus 3. If I compare these two now, the difference is 2. Compare this one, the difference is what? Difference is 4. Compare this one, the difference is 5. Compare this one, the difference is 8. So this one now tends to have the is the biggest. So all these things are logic. Use logic to do it so that you don't waste time unnecessarily. So we'll be stopping here for this video. We'll continue in the next video. I hope this video has been informative for you. I'd like to thank you for viewing.